Today we'll start with model number 5, that is reciprocating air compressors. Now, as the name itself indicates, we are dealing with a chapter known as compressors. Now, what will be a compressor? We all know that a compressor is a machine. That is, what does it do? It's a machine that compresses the air from the atmosphere, which take the air from the atmospheric pressure and raises its pressure until the required pressure. Now, where that this compressor delivers it, this delivers to the storage tank. There is a storage vessel that is connected. From the storage vessel, there are different pipelines. From that pipelines, we are using it for the different applications. Now we know that compressor is not, it is a work consuming device. It always requires some amount of input energy. For example, it always requires a prime mover. Now where we are finding the application of this, we are using this compressed air in pneumatic drills. We are using in riveters, in rod drilling, spray painting, etc. In combustion engines, gas turbine, we all are using these compressors. Now basically the compressors are classified into three types. How they are classified? They are classified according to their working. According to the working means their working action or working principle. It may be reciprocating compressors or rotary compressors. According to the number of stages, they are classified as single stage compression and multi stage compression. And according to their action, they are classified as a single acting compressors and multi stage compressors. Okay. Now in order to move further in the chapter, we need to know some technical terms. Now this technical terms is, we need to know what is inlet pressure, what is discharge pressure, what is the swept volume, what is compression ratio, what is free air delivery, etc. This is the following small few things. These are the few things. These are the few things we need to know before proceeding in this chapter. Now, as you all know, inlet pressure means what? The pressure which is available at the inlet of the compressor. For example, atmospheric pressure. If you are taking the air at the atmospheric pressure, that will be your inlet pressure. What is discharge pressure? The pressure that is available at the outlet of the turbine. For example, if you want to have a pressure of 10 bar, then what I should do? The discharge pressure will be of unit 10 bar. Now, what is inlet pressure? If inlet pressure that is available is 1.01 bar, then that is my inlet pressure. Now after inlet discharge pressure, there are different terminologies like compression, compressor capacity. Now what is compressor capacity? The volume of air that is left with the compressor is known as compressor capacity. It is expressed in meter cube per seconds. Now what is swept volume? The volume of air sucked to the compressor during suction stroke. Nothing but is swept volume. How it is given mathematically? Pi by 4 d square into L. What is d? D is diameter of the cylinder and L is length of the stroke. That is nothing but swept volume. Okay, then what is these are the few technical terms which you know. Now we'll see the working principle of this reciprocating air compressor. Now see here, as you can see in the diagram, what is the this is working of single stage reciprocating air compressors. Now what this all consists of? Reciprocating means what are the reciprocating devices which commonly know? Piston and cylinder is the only reciprocating device which comes in which we know. Now see, for the piston and cylinder to have, we should have one piston, we should have one cylinder, we should have one inlet and discharge valves, and another is storage vessel. These are the main components of a single stage reciprocating compressors. Now see in this diagram, you can see this is my cylinder, this is the piston, this is the discharge valve, this is my inlet valve. Now see here what happened basically. Now see here, we know that outside this area, outside this line, there is atmospheric pressure. That outside the cylinder there is atmospheric pressure, and inside, now see in the suction stroke, when this piston starts to move downwards, that is when the piston moves downward, there is vacuum created inside, right? Inside abhi kya hua? Inside there is vacuum, outside there is atmospheric pressure. Now what happened? There is pressure difference. There is P ATM minus P vacuum, because we are having the pressure difference. Now due to this pressure difference, what happened to the inlet valve? The inlet valve will get open. Okay, the inlet valve will get open. As this inlet valve opens, the fresh air from the atmosphere comes inside the cylinder. Now this is my what? This is my suction stroke. Now what happened next? This piston, how much amount of air enters into this piston cylinder? Amount by which this piston moves downward, total till here, the air is sucked inside this cylinder. This is nothing but suction stroke. Now what happened? Until this piston moves to the bottom dead center, the valve get closed. This inlet valve will close since the piston reaches its bottom dead center. Now what happened? Once this piston is moving inside, now see, you can see in this diagram, the piston starts to move upwards. As this piston starts to move upward, the pressure of this air that is inside this cylinder starts to increase. Till how much amount it increase? As this valve moves upward, the pressure increases. Due to this pressure, this air will exert pressure on this discharge valve, and this discharge valve get opens. And see here, this inlet valve is closed because it was closed in the first case only when the piston is moving to the bottom dead center. Now, as soon as this piston moves up, the air will exert this some amount of air. I'm pushing it from backward, so there is pressure, right? So this pressure will exert pressure on this valve, so this discharge valve opens and the air will get discharged to the to the pipelines or the storage vessel. Now see here, we are having some amount of free space or the clearance volume. There is clearance volume. In that clearance volume, some amount of this high pressure air will be will occupy the space in this clearance volume. What high pressure will be occupied. Now once this valve is open, discharge valve is open and all air is discharged, this discharge valve closes due to different pressure difference. Now when this piston again, since the piston will be spring loaded always, the piston is not in the top dead center, it always tries to come down or move downward into the bottom dead center. Now once this piston starts moving at the bottom dead center, the air that is present inside this clearance valve starts to expand. As this air expands, there is again pressure difference, and again this inlet valve opens, and again the fresh air is taken inside, and the cycle repeats. Now see here, as it is on a single stage, we are doing it single stage. We are doing a single stage because it takes place in two stroke of the pistons or one revolution of the crankshaft, and therefore we are calling it as single stage reciprocating air compressor. Now see, we can draw the PV and TS diagram for this. The PV and TS diagram can be represented like this. See here. Now we can draw the TS diagram for this reciprocating air single stage reciprocating air compressor. Okay, see, we can draw the PV diagram for this. Now what is 1 to 2? We know that 1 to 2 is isentropic. What is pressure 1 to 2? Isentropic. Compression was process 1 to 2. This is constant. Okay, now see, this is constant pressure. Again, this is, what is this? This is again constant volume, and this is again constant pressure. So all the four process, 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 6. This is nothing but my PV diagram for this reciprocating single stage air compressors. Now what is application of steady flow energy equations? Now SFE means steady flow energy equations. Now see here in this diagram, we have a control volume. It is indicated. I have a piston and cylinder. This piston and cylinder arrangement, air is inside. This is inside air, it is sucking inside the cylinder. This is outside, high temperature is taken to the receiver and from your pipeline. Now see here, what is Q122? Heat is rejected. This is what work done on the system. Now if I apply the steady flow energy equations, what I will do? What is steady flow energy equation? Steady flow energy equation consists of all the energies. That is internal, that is total energy of the system, heat supplied to the system, and work W1, there is work done by the system or on the system. Now after applications, here I can write this M into H, this internal energy plus kinetic energy plus potential energy plus heat supplied should be always equal to the internal energy on the another side, kinetic energy on the another side, potential energy on the other side, and work done or work supplied. Now see. Now see here, the system is constant, it is not running, so kinetic energy becomes 0, and since it is related to the ground level, potential energy becomes 0 or neglected. Now what is remaining? M into H1 plus Q122 equals to M into H2 plus W122. Now we know that heat is rejected by the system or rejected by the air, so I will take heat as negative, and we are supplying the work to the compressor, work absorbing device है compressor, so W122 will be negative. Now if I apply this, what is remaining? M into H1 minus Q122 equals to M into H2 minus W122. So what will W122? W122 is equals to M is constant into H2 minus H1 plus Q122. What is M? M is mass of the air, H2 minus H1 change in internal energies, plus Q122 is your heat supplied.